In this video, we're going to focus on these three properties for segments in circles. And so take a minute if you need to pause, look at those properties, and once you feel like you kind of had a chance to look at them all, go ahead and continue the video. So from here, what we're going to do is we're going to apply these properties into solving problems to solve missing lengths of segments in the circle. So let's take a look at some of those problems. So here, starting with this problem here, this problem I see kind of has rule 2, where this segment is congruent to this segment. Because it tells me that here, those two segments are congruent. And so what that means is that CD has to be congruent to AB as well, because they are the same distance from the center. So with that in mind, then I know that CD and AF are going to have some type of relationship. But it's not going to be the exact same relationship as just being equal, because AF is just this piece. And so that comes in the other property that says if a radius is perpendicular to a chord, then these chords are bisected. So that means that if I multiply AF by 2, then I should get AB, and I can set that equal to CD. So let's look at that. The equation is going to be 2 times 2x minus 5, because 2 of those will make the whole line, is going to be equal to 3x plus 10, my value of CD. Now from here we would just need to solve this. So we get 4x minus 20 is equal to 3x plus 10. Get your x's together and get x minus 20 equals 10. Add the 10 to both sides, so we can get x is equal to 30. Now we're not done with the problem because it doesn't say just solve for x. It says also what is the length of AB. So to get that length, what we're going to do is we're going to say, well, I know AB is the same as CD, so I can say that AB is equal to 3 times x, which we found to be 30, plus 10. And so we simplify that and we get that AB is 100. And that is our final answer. The next problem is still dealing with those three properties, but it's a little different, so let's take a look at it. So first thing, let's read through the problem and mark out what it says. It says arc CB, so C to B, is congruent to arc DB, so D to B. So that arc is congruent to that arc. Okay, so if that's true, that means that based off our properties that this segment is congruent to that segment. We also know that's true because we have a diameter here with a perpendicular to that chord. So that also means those two parts are congruent. Alright, so next piece says that DC, this whole line from here to here, is 24. And that OE, so this little piece in here, is 9. What is the measure of OB? So what is the measure of this here, which happens to be our radius? Okay. So what we need to do in a problem like this is we kind of need to be a little creative. And we need to say, okay, well, if I know that this line here is 9, let's get some new colors here. I know this line here is 9. And I know the whole line from C to D is that 24. This piece is going to be half of that, so that's got to be 12. And so we notice here, we're getting kind of the start of a right triangle. We just need this piece to finish out that right triangle. Now, that piece, that's a radius because it's from the center to a point on the circle. And if that's a radius, that means it must be equal to that radius. And because this creates a right triangle here, I can use the Pythagorean theorem to solve for my radius. So I get 9 squared plus 12 squared is equal to r squared. And then I just need to solve. So I get 9 squared, that's 81, plus 12 squared, that's 144. It's going to equal r squared. We add those up, we get 225 is equal to r squared. Now we just take the square root of both sides and we get that our radius is 15. And that's it for that problem. The tricky part here is we have to remember to draw in that extra radius. We have to get a little creative with these side lengths to identify them there. But that's it. So that finishes up our review. Keep in mind, if you don't have this review, it's linked down in the video description. And have a good day.